yeah, my first years in class where my nightmare was people asking me questions I didn't know the answer. Yeah. So now I have to solve what is this. The exterior surface. Now it's a ball, it's an empty. I want to know only the surface, but only the surface, not without thickness. Okay. So of radius r, yeah, I know the answer. So I have to 4 pi. It's easier because 4 pi r squared. I have to find the answer. So what I tried before was to consider a differential. So I have to cut it in slices, and if I choose the right slice, it will work. Otherwise, it won't. So what if I cut it in slices which are rings? Okay, so the differential element is a ring. Okay, empty, and then I changed. They're not all the same radius, right? No, that's a problem. They have different sizes, so that's a problem. So I will change, let's suppose that this is the axis, okay? And if I try to draw my sphere, it will be something like this, right? Different slices, okay? And then, but it's not, yeah, but you get an idea. And they are differential slices, okay? Differential slices, yeah. I remember seeing my favorite YouTube channel, which is My Mechanics. My Mechanics is the best. My Mechanics makes restorations and even makes small pieces. And I remember seeing him making a pool ball made out of steel. Yeah, with inserting some brass. And it is like this. It is like he cuts the cylinder into a piece like this, okay, even smaller, and then spin it around like this, okay, and he reduced this Sharpie, I don't know, the sharp rectangles into smaller and smaller and smaller, so it becomes a continuous line. So, which is what we really want. That's the idea of an integral. Polishing a lot, so it's a continuous. Okay, so but it's we have to take into account that it's made. What is that we have? It is made of small differential elements. Yeah, but I don't know how to start. So they are rings, and the thickness can be differential effects. That's no problem. Yeah, but the choice is crucial. What if I can? The problem is I don't see the dimensions very clearly. So yeah, I don't know whether to integrate using the angle or the radius. That's I don't know. I don't know about that. They don't have the same. They don't have the same radius. No. The radius is related to this angle. To this angle, because you see, this angle makes the size. Okay, and then it decreases. This angle must be important. What if I use trigonometry? Okay. So this is the radius of the differential element, call it with a small r. This small radius is related to what? Related to the angle and related to this distance, right? Yes, this distance, call it d. So r, using trigonometry, the cosine is this one, like the shadow, okay, and this is the sine. So r is d. It sounds familiar, like the sine for the integral, but I don't remember. Yeah, but about d? D changes or is constant? No. The distance. Each one has a different distance, so that's a problem. D changes from, see, this distance is, yes, this distance is the radius, okay? And here is 0. What if I do from the distance, let's call this, since it's the 0 is here, minus D to D. No, minus R, which is the radius, the size of the sphere, minus R to plus R. How about that? And the sign, yeah, but the relationship between sign. What is the relationship? Because if I have two variables, I have to do integration with only one variable. If I have two, with R it's more simple, but I don't know how to get the R. The R changes from 0 to R, yeah, that will be easier, right? Because the R, the radius changes from 0 to R, because, you know, since it's a sphere, you know, this is like a, yeah, all the dimensions, the diameters. At the end of a diameter, the distance is R from the center, right? You understand? With R will be easier, yeah, but what I need is, and also the thickness, right? I have to consider this thickness. This thickness is call it how? X. Yeah, if it's X, well, it's supposed, if I know X, well, I would know, instead of D, I would know this X, right? And next we change from minus R to plus R, right? Yes, minus R, then will be 0, and then plus R, so I will travel to all of the differential elements, okay? But what is the problem? What is the problem? Well, I can relate radius with X, because let me see. They are related through a tangent, right? Yes. Tangent of theta, or whatever I call it, is sine divided by cosine. Sine is D. No. Yeah, this is D. I don't remember. I think it's R divided by X, but I'm not sure. R divided by X, yeah, but integrating from 0 to 90, yeah, but when the angle is 90, I have a problem because this is not continuous. I could do the integration of half, because when theta is 90, then tangent of 90 degrees, that is infinite. A bad idea for an integral using the tangent. What about D? D, yeah, but I need R, don't not D. D doesn't make sense. So, as you see, I have absolutely no idea how to solve this. So for me, it's clear that each differential element must have a certain radius, okay? And then